Imagine our planet 4.5 billion years ago, a young fiery Earth. Molten rock covers its surface, no trace of the serene blue planet we know. This was a time of intense heat and chaos. Meteors rained down from space, volcanoes erupted, spewing lava and gas. Earth was a world in constant turmoil. This early Earth was a hostile place. No life could exist in such extreme conditions, but from this chaos, order would eventually emerge. The very events that made Earth uninhabitable were also the forces that would shape it into a life-bearing world. It's hard to imagine a time before oceans and continents, yet this was Earth's reality. The planet was a blank canvas, awaiting the brushstrokes of time and cosmic events. Over millions of years, the relentless bombardment and volcanic activity would begin to cool the molten surface. This cooling would be the first step in a long, incredible journey, a journey that would eventually lead to the emergence of life itself. The early solar system was a cosmic shooting gallery, a chaotic and violent place where countless meteoroids and comets roamed freely. These celestial bodies, remnants from the formation of the solar system, were constantly on a collision course with the young planets, including Earth. The early Earth was a very different place from the one we know today. It was a molten, hostile environment, with a surface that was constantly being reshaped by the impacts of these space rocks. Earth, still in its infancy, was constantly bombarded by meteoroids. These impacts were not just minor collisions, they were cataclysmic events that released enormous amounts of energy. Each meteoroid that struck the Earth contributed to the planet's heat, melting the surface and creating vast pools of molten rock. This period of intense bombardment is known as the Late Heavy Bombardment, and it played a crucial role in shaping the early Earth. These celestial wanderers, remnants from the solar system's formation, crashed onto the young planet with incredible force. The impacts were so powerful that they could vaporize rock and create massive craters. Some of these craters were hundreds of kilometers in diameter, and their formation would have been accompanied by massive shock waves and intense heat. The energy released by these impacts was enough to melt large portions of the Earth's crust, contributing to the planet's molten state. Each impact unleashed tremendous energy, heating the Earth's surface and adding to its molten state. The heat from these impacts caused the surface to become a seething molten landscape with rivers of lava flowing across the surface. This intense heat also caused the release of gases trapped within the Earth's interior, which began to form a primitive atmosphere. The early Earth's atmosphere was very different from the one we have today. It was composed mainly of carbon dioxide, water vapor, and other volcanic gases. Volcanoes, too, played a crucial role. They erupted frequently, spewing molten rock, gas, and ash into the atmosphere. These volcanic eruptions were driven by the intense heat and pressure within the Earth's interior. As the molten rock, or magma, rose to the surface, it carried with it gases that had been trapped deep within the Earth. When the magma reached the surface, these gases were released in explosive eruptions, sending ash and gas high into the atmosphere. These eruptions released trapped gases from Earth's interior, contributing to the formation of a primitive atmosphere. The gases released by volcanic eruptions included water vapor, carbon dioxide, sulfur dioxide, and other volatile compounds. Over time, these gases accumulated in the atmosphere, creating a thick, dense layer that enveloped the planet. This early atmosphere was very different from the one we have today. It was much thicker and more toxic, but it was a crucial step towards creating a habitable environment. While toxic by today's standards, this early atmosphere was a crucial step towards habitability. The thick layer of gases helped to trap heat, creating a greenhouse effect that kept the planet warm. This was important because the young sun was not as bright as it is today, and without this greenhouse effect, the Earth would have been too cold to support liquid water. The presence of liquid water is essential for life as we know it, and the early atmosphere played a key role in maintaining the conditions necessary for water to exist on the surface. The meteoroid impacts and volcanic eruptions were not isolated events. They happened over millions of years. This constant bombardment and volcanic activity had a profound effect on the Earth's evolution. The impacts and eruptions helped to shape the planet's surface, creating craters, mountains, and valleys. They also contributed to the formation of the Earth's crust, as the molten rock from volcanic eruptions cooled and solidified. This constant bombardment and volcanic activity had a profound effect on Earth's evolution. The impacts and eruptions helped to shape the planet's surface, creating craters, mountains, and valleys. They also contributed to the formation of the Earth's crust, as the molten rock from volcanic eruptions cooled and solidified. Over time, the Earth's surface began to stabilize and the planet started to cool. This cooling allowed for the formation of solid land masses and the development of a more stable atmosphere. The impacts helped to shape its early surface, creating craters and depressions. These craters and depressions would later become the basins for the first oceans. As the Earth cooled, water vapor in the atmosphere condensed and fell as rain, filling these basins and creating the first bodies of water. The presence of liquid water on the surface was a crucial step towards the development of life, as it provided a medium for chemical reactions to occur. The volcanic eruptions released gases that would eventually form the building blocks of our present atmosphere. These gases included water vapor, carbon dioxide, and nitrogen, which are essential for life as we know it. Over time, the composition of the atmosphere changed, as plants and other organisms began to produce oxygen through photosynthesis. This gradual increase in oxygen levels eventually led to the development of the ozone layer, which protects the Earth from harmful ultraviolet radiation. Together, these cosmic architects, through their destructive power, were laying the foundation for a habitable Earth. The meteoroid impacts and volcanic eruptions, while violent and destructive, were essential in creating the conditions necessary for life to develop. They helped to shape the planet's surface, create a stable atmosphere, and provide the building blocks for life. Without these processes, the Earth would be a very different place, and life as we know it may never have existed. The atmosphere of early Earth was vastly different from what we breathe today. Imagine a world where the sky was perpetually shrouded in thick, toxic clouds, and the air was a suffocating mix of noxious gases. This was a time when the Earth was still in its infancy, a volatile and hostile environment that bore little resemblance to the blue and green planet we now call home. It was a toxic mix, devoid of free oxygen. The air was thick with gases that would be deadly to most forms of life today. The sky was a murky haze, filled with particles and chemicals that created an almost alien landscape. There were no plants to produce oxygen, no animals to breathe it in. The atmosphere was a cocktail of methane, ammonia, and carbon dioxide, creating a greenhouse effect that trapped heat and made the surface of the planet unbearably hot. Dominated by gases like methane, ammonia, and carbon dioxide, the early atmosphere was a far cry from the life-sustaining air we depend on today. These gases were constantly being spewed into the atmosphere by the numerous active volcanoes that dotted the planet's surface. The volcanic activity was relentless, with eruptions occurring on a scale that is hard to imagine. Each eruption released more gases into the atmosphere, further contributing to the thick, toxic air. This early atmosphere would be unbreathable to most life forms we know today. The surface of the Earth was a barren, rocky wasteland, devoid of any signs of life. The ground was scorched and cracked, with no vegetation to provide shade or shelter. The intense heat and toxic air made it impossible for any life forms to survive. It was a harsh and unforgiving environment where only the most extreme conditions prevailed. Temperatures on Earth soared due to the thick atmosphere and the constant volcanic activity. The heat from the volcanic eruptions, combined with the greenhouse effect created by the gases in the atmosphere, made the surface of the planet incredibly hot. Lava flowed freely from the volcanoes, creating rivers of molten rock that scorched the land. The air was filled with ash and smoke, further contributing to the thick haze that enveloped the planet. The surface of the planet remained scorching hot. The ground was so hot that it would have been impossible to walk on it without being burned. The heat was intense, and there was no escape from it. The landscape was dominated by hot deserts and geothermal hot springs, where the water was heated to boiling temperatures by the heat from the Earth's interior. It was a world of extremes where the heat was relentless and unforgiving. The intense heat made liquid water impossible. Any water that did exist on the surface of the planet was quickly evaporated by the heat, turning into steam and rising into the atmosphere. The ground was dry and cracked with no signs of moisture. The air was filled with steam, creating a misty, otherworldly landscape. It was a world where water could not exist in its liquid form, only as vapor in the atmosphere. Instead, any water present existed as vapor in the atmosphere. The air was thick with water vapor, creating a humid and oppressive environment. Clouds of steam rose from the ground, adding to the already thick haze that enveloped the planet. The water vapor in the atmosphere played a crucial role in the greenhouse effect, trapping heat and making the surface of the planet even hotter. It was a vicious cycle where the heat created more water vapor, which in turn trapped more heat. This period, known as the Hadean Eon, was a time of unimaginable heat and a hostile, unbreathable atmosphere. The Hadean Eon was the earliest period in Earth's history, lasting from the formation of the planet about 4.6 billion years ago to around 4 billion years ago. It was a time when the Earth was still forming and the conditions were incredibly harsh. The heat was intense and the atmosphere was filled with toxic gases. It was a world that was constantly changing, with volcanic eruptions and meteor impacts shaping the landscape. Yet even in this toxic embrace, the seeds of change were being sown. Despite the harsh conditions, the early Earth was a dynamic environment where the building blocks of life were beginning to form. The volcanic activity and the presence of water vapor in the atmosphere created the perfect conditions for chemical reactions to occur. These reactions would eventually lead to the formation of complex molecules, the precursors to life. It was a time of great change, where the foundations of life were being laid. The very gases that made the atmosphere poisonous would, over time, play a crucial role in the development of life. The methane, ammonia, and carbon dioxide that filled the early atmosphere were not just toxic gases, but also the building blocks for more complex molecules. These gases interacted with each other and with the water vapor in the atmosphere, creating a rich chemical soup. This soup would eventually give rise to the first simple life forms, setting the stage for the evolution of more complex organisms. They would be the building blocks for complex molecules, the precursors to life. The early Earth was a giant laboratory where the ingredients for life were being mixed and combined in countless ways. The volcanic activity provided the heat and energy needed for chemical reactions to occur, while the water vapor and gases in the atmosphere provided the raw materials. Over time, these reactions would lead to the formation of more complex molecules, such as amino acids and nucleotides, which are the building blocks of proteins and DNA. The early Earth may have been a hellish landscape, but it was a dynamic environment. The constant volcanic activity and the presence of water vapor in the atmosphere created a world that was constantly changing. The landscape was shaped by volcanic eruptions, meteor impacts, and the movement of tectonic plates. It was a world of extremes where the conditions were harsh and unforgiving, but also full of potential. The early Earth was a place where the building blocks of life were being formed, setting the stage for the evolution of more complex organisms. Change was the only constant, and this constant change would eventually pave the way for a more hospitable planet. Over time, the volcanic activity would decrease, and the atmosphere would begin to stabilize. The toxic gases would be replaced by oxygen, produced by the first simple life forms. The surface of the planet would cool, allowing liquid water to exist. The early Earth was a world of extremes, but it was also a world of potential, where the foundations of life were being laid. It was a time of great change where the seeds of life were being sown, setting the stage for the evolution of the complex and diverse life forms that we see today. The miracle of water from vapor to oceans. Water, the essence of life, has a journey that is as ancient as the Earth itself. It is a journey that began in the fiery depths of our planet's early history and continues to shape the world we live in today. This is the story of how water transformed from mere vapor into the vast oceans that cover our planet. As Earth began to cool, a remarkable transformation occurred. The planet, once a molten ball of fire and lava, started to solidify. Volcanic activity was rampant, with eruptions spewing gases, including water vapor, into the atmosphere. This was a time of intense geological activity where the very surface of the Earth was being reshaped by the forces of nature. The water vapor in the atmosphere began to condense. As the temperature dropped, the vapor coalesced into clouds, creating a thick, misty blanket that enveloped the planet. This was the beginning of a new phase in Earth's history, where the atmosphere played a crucial role in the formation of liquid water. Rain fell upon the cooling surface of the planet. Torrential downpours, unlike anything we see today, drenched the barren landscape. These rains were relentless, pouring down for thousands of years, slowly but surely altering the face of the earth. The once dry and desolate terrain began to change, as water started to carve its path through the rocky surface. At first, the rain would have sizzled and evaporated as it hit the hot ground. The intense heat from the Earth's surface caused the water to turn back into vapor almost instantly. This cycle of evaporation and condensation continued for eons, gradually cooling the planet further and allowing more water to remain in its liquid form. But as Earth continued to cool, the water remained liquid, forming pools and streams. These small bodies of water were the precursors to the vast oceans we know today. They collected in low-lying areas, creating the first lakes and rivers. Over time, these water bodies began to connect, forming a network of streams and tributaries that crisscrossed the landscape. Over millions of years, these small bodies of water merged, becoming larger and deeper. The streams and rivers fed into larger basins, gradually filling them with water. This process was slow and steady, taking place over geological timescales. The merging of these water bodies was a crucial step in the formation of the Earth's oceans. Gradually, they carved out vast depressions in the Earth's surface. The relentless flow of water eroded the rocky terrain, creating valleys and basins. These depressions became the cradles of the first oceans, where water could collect and remain. The landscape was being sculpted by the power of water, transforming it into a more hospitable environment. These depressions would eventually become the basins for the first oceans. As the water continued to flow and accumulate, these basins grew larger and deeper. The early oceans were born, covering vast areas of the Earth's surface. These bodies of water were teeming with potential, setting the stage for the emergence of life. The formation of liquid water on Earth's surface was a pivotal moment in its history. It marked the transition from a hostile, barren planet to one that could support life. Water is the lifeblood of our planet, and its presence was essential for the development of the complex ecosystems we see today. The early oceans were the cradle of life, providing the necessary conditions for the first organisms to thrive. Water is essential for life as we know it. It is a solvent, a medium for chemical reactions, and a habitat for countless organisms. Without water, life as we know it would not exist. The presence of liquid water on Earth was a prerequisite for the emergence of even the simplest organisms. It provided the environment in which life could begin and evolve. Its presence on Earth was a prerequisite for the emergence of even the simplest organisms. The early oceans were teeming with microbial life, the first forms of life on our planet. These simple organisms were the building blocks of more complex life forms, setting the stage for the incredible diversity of life we see today. The formation of oceans was a turning point in Earth's history, marking the beginning of the biosphere. The formation of oceans marked a turning point, setting the stage for the next chapter in Earth's evolution. The planet was no longer a dry, barren wasteland. It was now a world where life could potentially take hold. The early oceans were the birthplace of life, providing the conditions necessary for the first organisms to thrive and evolve. The planet was no longer a dry, barren wasteland. The presence of water transformed the landscape, turning deserts into lush, fertile areas. The early ecosystems began to take shape, with plants and animals adapting to their new environment. The formation of oceans was a key factor in the development of these ecosystems, providing the water and nutrients needed for life to flourish. It was now a world where life could potentially take hold. The early oceans were the cradle of life, providing the conditions necessary for the first organisms to thrive and evolve. The formation of oceans was a turning point in Earth's history, marking the beginning of the biosphere. The presence of water transformed the landscape, turning deserts into lush, fertile areas. The early ecosystems began to take shape, with plants and animals adapting to their new environment. The formation of oceans was a key factor in the development of these ecosystems, providing the water and nutrients needed for life to flourish. A planet transformed, the birth of continents and oceans. As Earth continued to cool its molten outer layer, the mantle began to solidify. This process, known as plate tectonics, would dramatically reshape the planet's surface. The Earth's crust fractured into massive plates, which moved and collided over millions of years. These collisions pushed up mountain ranges and formed deep ocean trenches. The constant movement of these tectonic plates had a profound impact on the distribution of land and water. Volcanic eruptions, a result of these plate interactions, continued to release gases into the atmosphere. The atmosphere, though still toxic, was slowly evolving. The formation of continents and oceans marked a turning point in Earth's history. It created diverse environments, from shallow seas to towering mountains. This diversity of habitats would prove crucial for the development and diversification of life. A stage set for life, how chaos bred order. From a fiery, chaotic beginning, Earth had transformed into a planet with oceans, continents, and a dynamic atmosphere. The very events that had made early Earth so hostile, the meteoroid bombardments, volcanic eruptions, and toxic atmosphere, had also shaped it into a world where life could emerge. The stage was set. The oceans provided a cradle for the first life forms. The atmosphere, though still evolving, now contained the building blocks necessary for life. And the dynamic geology of the planet, driven by plate tectonics, provided a variety of environments for life to evolve and diversify. The story of Earth's journey from chaos to life is a testament to the power of time and change. It's a story that reminds us that even in the most extreme conditions, the seeds of life can find a way to take root and flourish.